Since computers were first around, there's been an effort to create software that mimics the human brain. The logic is that if the brain is a computer, we should be able to replicate the brain using, well, a computer. But there's a problem. Your brain is the most complex machine that has ever existed in the known universe. Using a modern computer, playing just a second of brain activity uses a petabyte of memory. By comparison, playing 2,000 years of MP3s on that same computer also uses a petabyte of memory. That's 2,000 years of music versus 1 second of brain activity. This is where neural network models come into play. Neural network models create a realistic yet simplified model of the brain on our computers so that we can simulate a few minutes of the brain's functioning on a timescale that doesn't take, literally, more hours than in human history. These neural networks have been around for years, but brand new technology has taken these neural networks out of the research lab and onto personal computers, allowing anybody with coding experience to manipulate these models. Researchers and hobbyists use this new technology for a range of purposes. Some use it to make models of the way the brain moves muscles. Others use it to create neural networks that learn the meanings of words and sentences. I have used this technology to create Dana. Dana, or Designer as Neural Activity, applies this new technology to design objects. This is Dana's brain. Each small gray square is a simulated neuron, and each yellow, orange, and red cube growing out of these gray squares indicates that the neuron is firing and communicating with other neurons in the network. As you can tell, the firing of neurons in this network doesn't look much like designing. This makes sense. You wouldn't look at a designer's brain to see his or her ideas, you would look at what he or she was making. But this is one of the strengths of Dana. She uses an algorithm that permits us to instantly convert her brain activity to images of the objects she is designing. In this way, we can not only see what Dana's gray matter is doing, like here, but we can produce visual images of the iterative process as she solves design problems. In this sense, these images are what she is thinking. So, here's the way Dana thinks. She is given a 3D workspace, and we give her an assignment to make, say, a stool, with a set of 4 legs, a seat, and a footrest. Her first attempt is chaos, a failure of greens, blues, and blacks. Then she compares what she has made to what we have told her to make, a simple stool, and she thinks, no, that's definitely not right. It's completely chaotic. There's no seat. It can't even be deciphered as a stool. So she tries again. It's closer, and you can sort of decipher that there's maybe a stool in there, but it's definitely not right. So she tries again, closer, but definitely not right. And then she tries again. And then finally, again. Each try she gets closer and closer to the stool we told her to make until, here we go, she makes that iconic form we all know. When we start over from scratch, erase her memories, and give her a new 3D workspace, she learns the task in an entirely different way. This means that Dana is capable of producing an infinite number of forms. Dana is also doing this process at such a fast timescale that it only takes her a minute to create hundreds of designs. What's so exciting about this process is that the artifacts of neural network learning manifest themselves visually in Dana's designs. For example, on some trials, she never fully learns to make the stool, and her brain gets stuck on the incorrect solution, much in the way your mind gets stuck on the wrong answer when the correct word is on the tip of your tongue, but you can only think of the incorrect word. Here, the footrest always stays as black bars floating beneath the seat, even on the 1,000th try. At other times, when Dana makes an error, she overcompensates by making the exact opposite error in the next iteration. So, if she makes the seat too small in the first trial, she'll overcompensate by making the seat infinitely large in the next, as we see here. Visually, this means that Dana creates objects that no human mind would ever create. But where some might see mistakes, these are actually opportunities for a new way of design thinking, brought from the imagination of artificial brains to ours.